Okay, calculus fans, let's say we have this function y equals x to the x and we need to find the derivative. Well, we've got a couple functions that look similar, something like y equals x cubed. This is a power function, but the problem with this one is the power function needs this power to be a real number. So if it were y equals x cubed, this is an easy problem. Y prime would be 3x squared by using the power rule. But it doesn't work because we've got no constants, two variables. Likewise, if we had something like y equals 3 to the x, well, this is an exponential function, but in this case, we've got a constant for the base, whereas here we had a constant for the power. Well, we have the derivative for this too. That one we know. The derivative of that would be y prime equals 3 to the x times the natural log of 3. So once again, the problem with this is there's no constant. These are both variables, so neither of these techniques work. So what we're going to do with this one, we're going to need to get it out of this form because there is just no solution that works for all of this type of problem. I can't just say y prime equals and there's a nice little formula here. It doesn't exist. So what we have to do is get it out of this form, and we'll do that using logarithms. Remember, there are 3 rules of logarithms, and these rules provide a way to simplify mathematical operations. So this mathematical operation of multiplication, we can simplify that into addition because the log of a times b is equal to the log of a plus the log of b. For division, instead of division, we could simplify that into subtraction. And for exponentiation, so we got this power here, log of a to the b. Instead, we can make this power come out and become a multiplier. So exponentiation becomes multiplication. So we've simplified these mathematical operations. And what we're going to do here, we're going to use this third one. If we take the log of each side, or I'll take the natural log. Usually in calculus, you use log base e, the natural log. So if I take the natural log of each side here, then I can use this rule. So I'm just doing what we know we can do if we've got an equation. I can do anything I want to this side as long as I do the same thing to this side. So I'm going to take the natural log of each side, and now we can use this rule, and this x can come down in front. This gives us the natural log of y equals x times the natural log of x. X times the natural log of x. Well, if we're multiplying, now we've got the product rule. And from here, we're all set. We've got the product rule. As long as we're careful about this, this is not the natural log of x. So when we differentiate, because we're looking for the derivative, we differentiate each side of this equation with respect to x. We need to remember that y is not x. We could think of y as a function of x, which it is, right? Y is a function of x. So when I take the derivative of natural log of y, it's going to be the derivative of natural log of y will be 1 over y. But then since this y is not plain old x, I need the chain rule. So I'm going to take the derivative here. I'm going to get 1 over y times y prime because that's not plain old x. Now over here I've got the product rule. The way this is typically taught is first term times the derivative of the second term plus the second term times the derivative of the first term. So that gives us this. So then we've got 1 over y times y prime equals x times, well, the derivative of natural log of x is 1 over x. And then the derivative of x with respect to x is just 1. And then we could clean this up because x times 1 over x is just 1. So that would give us 1 over y times y prime equals 1 plus the natural log of x. So at this point, we're pretty close. We're almost to y prime, which is what we want. But look what we've got. We've got over here, we've got 1 over y times y prime. We just want y prime, so we need to get rid of this 1 over y. Well, we know we can get rid of 1 over y if we multiply each side by y. So I can multiply this by y as long as I multiply this by y. That would cancel, giving us y prime equals, but now we don't want y in our answer, right? Our question was y equals x to the x. But that's okay because y, we know what y is. Y equals x to the x. So let me do this in 2 steps. We could write y times 1 plus the natural log of x, right? That's basically what we've got here. But we don't want y. We want our answer to be in terms of x. No problem. We know y is exactly the same as x to the x. So that our final answer will be y prime equals x to the x times 1 plus natural log of x. And that same technique can be used on anything like this. Like if you have, for instance, y equals x to the sine of x, y equals cosine of x to the 1 over x. Anything like this where these don't fit either the power rule, right? So these don't fit either the power rule or this exponential function rule. If there's a variable in the base and also a variable in the power, like there are here and here, then just use natural logs, and the same technique works on all of those problems.